Carbon is found in the native form as graphite, coal, crude oil, and carbonate rocks such as calcite, magnesite contains large quantities of carbon in its combined form with other elements. Silica occurs as silica, sand, and quartz crystals. Silicate materials, minerals, and clay are other important sources for silicon. Some of the physical properties of group 14 elements are listed below. That catenation is an ability of an element to form chain of atoms. The following conditions are necessary for catenation. Valency of element should be greater than or equal to 2. Element should have the ability to bond with itself, and self bond should be as strong as its bond with other elements. Kinetic inertness of catenated compound towards other molecules. Carbon possesses all the above properties and forms a wide range of compounds with itself, with other elements such as H, O, N, S, and halogens. Carbon exists in many allotropic forms. Graphite and diamond are the most common allotropes. Other important allotropes are graphene, fullerenes, and carbon nanotubes. Graphite is the most stable allotropic form of carbon at normal temperature and pressure. It is soft and conducts electricity. It is composed of flat two-dimensional sheets of carbon atoms. Each sheet is a hexagonal net of sp2 hybridized carbon atoms with a C bond length of 1.41 and which is close to the C bond distance in benzene 1.40. Each carbon atom forms three bonds with three neighboring carbon atoms with three of its valence electrons, and the fourth electron present in the inhibitized p orbital forms a pi bond. These pi electrons are delocalized over the entire sheet, which is responsible for its electrical conductivity. The successive carbon sheets are held together by weak van der Waals forces. The distance between successive sheets is 3.40 Armstrong. It is used as lubricant either on its own or as a graphited oil. Unlike graphite, the other allotrope diamond is very hard. The carbon atoms in diamond are sp3 hybridized and bonded to four neighboring carbon atoms um, by sigma bonds with a CC bond length of 1.54 Armstrong. This results in a tetrahedral arrangement around each carbon atom that extends to the entire lattice. Fullerenes are newly synthesized allotropes of carbon. Unlike graphite and diamond, these allotropes are discrete molecules such as C32, C50, C60, C70, C76. These molecules have cage-like structures as shown in the figure. The C60 molecules have a soccer ball-like structure and is known as Buckminster fullerene or buckyballs. It is a fused ring structure consists of 26 membered rings and 12 5-membered rings. Each carbon atom is sp2 hybridized and forms three sigma bonds and a delocalized pi bond, giving aromatic character to these molecules. The C bond distance is 1.44 Armstrong, and C double bond C distance is 1.38 Armstrong. Carbon nanotubes, another recently discovered allotropes, have graphite-like tubes with fullerene ends along the axis. These nanotubes are stronger than steel and conduct electricity. They have many applications in nanoscale, electrics, catalysis, polymers, and medicine. Another allotropic form of carbon is graphene. It is a single planar sheet of sp2 hybridized carbon atoms that are densely packed in a honeycomb crystal lattice. Carbon monoxide can be prepared by the reaction of carbon with limited amount of oxygen.